Okay, Bismillahirrahmanirrahim. Assalamualaikum and salam sejahtera. Okay, so today we will continue techniques on differentiation part 2. Okay, so we will discuss about the big topic is parametric, implicit and logarithmic differentiation. Okay, first we go through for parametric. Okay, so parametric differentiation. Okay, so in this case where both y and x depend upon a third variable t. Okay, so the third variable is called a parameter. Okay, so the derivative, which is dy over dx, can still be found using the chain rule. Okay, but maybe it is slightly different. Okay, in this form. Okay, we just have quotient or fraction form. Okay, so this also called as parametric differentiation. Okay, so we just look at the first example here. Okay, so we have to find dy over dx or y prime. Okay, given y is equal to 1 plus t and then in bracket square. So and then we have here x equal to 2t. Okay, x equal to 2t. So in this case, we just do the differentiation for y. So it will be dy over dt. So before that, we have to expand first. So when expand, it will become 1 plus 2t and plus t squared. Okay, so dy dt is equal to 2 plus 2t. Okay, and then we differentiate x. Okay, dx over dt. So we have 2. Okay, and then so for parametric differentiation, okay, we have dy over dx equal to dy over dt and then multiply with not multiply, but it is over. Okay, okay, over just the same. Okay, the upper acronym will be same. Okay, so it will be dy over dx. The lower acronym will be the same, dx over dt. Okay, so and then so dy x is, so dy dt is 2 plus 2t, right? Okay, 2 plus 2t. 2t. Okay, and then over 2. So simplify, it will become 1 over 1 plus t. Okay, and then since we want in x term, so we have to convert t into x term. So here, small. Okay, so here, so t is this one. So you just convert. So t is equal to x over 2. We just convert here. dy over dx is y plus x over 2. Okay, so that's it for the example. Okay, and then we go for next example. Just go straight to implicit differentiation. Okay, so what is implicit differentiation? Okay, in this case, it is implicit where it is impossible to write the equation in the form y equal to function of x, which means here we cannot separate y and x. Okay, cannot be separately written. Okay, so in this case we have y and then we have y here, so we cannot separate. Okay, y and x. Okay, and then okay, so we say y is expressed implicitly in terms of x. Okay, and then if can separately written in this form, so it is called explicit. Okay, so usually dy over dx or the y prime will be expressed in terms of both x and y. Okay, and then here we will use chain rule. Okay, in this case we need to differentiate to a function of y. Okay, usually we just to a function of x, right? Okay, in this case we have differentiate a function of y. Okay, so let's look at the example. Okay, so let's say find d over dx by 4. Okay, so notice here that in this case we have to differentiate of x, but here we have only information of y. Okay, so we have to use the implicit method. Okay, since you can say not same, having not having same not having same element. Okay, so okay, now we have to let z, okay, let z equal to y over 4. Okay, so it will become dz over dy, so differentiate, it will become 4y3. Okay, so so the main aim here is to find dz over dx. Okay, so we're going to eliminate y. Okay, so we have, so the main aim is we want to find dz over dx. So then we will have dz in this color, dz over dy. Okay, multiply with, let's say, dy over dx. Okay, so we are going to eliminate y here. Okay, so now So we have dz dx. Okay, right again. We have dz over dy, which is 4y to the power of 3. Okay, and then just write down dy over dx. Okay, so now we substitute z equal to y4. So we will have d over dx y to the power of 4 equal to 4y3 dy dx. Okay? Okay, next we will look at next example, which is I think 11.11 here. Okay? So find d over dt ln y, right? Okay, so again, we just convert ln y into z. Okay, so let z becomes the ln y. Okay, so the main aim here is to find dz over dt. So again, we just eliminate y. So dz over dt equal to dz over dy, then multiply with dy over dt. Okay, so we just differentiate z first. So dz over dy is equal to 1 over y. Okay, so we just write down this one. We have 1 over y, then in bracket dy over dt. Okay, just write back again. Okay, so we are going to convert z into ln y again. So it will be d over dt ln y in bracket will be equal to 1 over y dy dt. Okay. Okay, so this is generally the formula. Okay. Okay, so in this case we just convert it into z. Okay, let z equal to y, and then this one we just this one is we just dz over dy. Okay. Okay, now we look at next example, 11.13. Okay. So here, okay, so given x to the power of 3 plus y equal to 1 plus 1 over 3, right? Okay. We have to find dy over dx. Find dy over dx. Okay, so in this case, we see that we cannot separate x and y explicitly. So what we have to do, implicit differentiation. Okay, so what we have to do is we have to differentiate dy over dx left hand side, d dy dx at the right hand side. Okay, so this is the left hand side. Okay, everything that is on the left, and then we have right hand side, everything that is on the right side. Okay, so for left hand side we will differentiate over x. Okay, left hand side. Okay, and then in this case we are going to use the linearity concept. So the linearity properties. Okay, so it will become d over dx x to the power of 3 plus y. Okay, so we can differentiate by single element. Okay, so this one x to the power of 3 plus d dx y. Okay, so it will become 3x to the power of 2 plus dy dx. Okay, and then for right hand side, same, we have to differentiate over x, the right hand side terms. Okay, same, we are using linearity properties. Okay, so d dx 1 plus y over 3, y to the power of 3. Okay, and then so we just do one by one because it is linear, right? Okay, so 1 plus d dx y to the power of 3. So this one will become 0. And this one, okay, notice that, okay, this is different. In this part it is y, and this part is x. So we have to use the chain rule. Okay, so again what we have to do is we just let z equal to y over 3. Okay, so again just write down the main aim here is small. Sorry, the main aim here is to find d z over dx. Okay, so dz over dx will be, so we are going to eliminate some y term. Okay, so it will become dz over dx dz over, we just, so dz over dy, and then multiply with dy over dx. Okay, so dz over dy is 3y to the power of 2. So dy to the power of 2, and then it is dy dx. Okay, so we just write down here it is equal to, this 0 is nothing, so it will be 3, y 3y squared, okay, dy over dx. Okay, so this is for the right hand side. Okay, now we just write again the left hand side and right hand side. Okay, so it become the equation again, right hand side. Okay, so on the right hand side there is, you can see this one, 3x to the power of 2 plus dy over dx equal to right hand side, which is 3y squared dy over dx. Okay, so what we have to do is, now we are going to find dy dx. Okay, so we are going to group dy dx in one point. Okay, so 3x squared equal to 3y squared dy over dx minus, okay, so we have 3x squared, then we have dy dx 3y squared minus 1. So dy over dx is equal to 3x squared over 3y squared minus 1. Okay, that's it for the differentiation. For implicit, okay, implicit differentiation. Okay, now we have to go next example, or what is next? Okay, jump straight to logarithmic differentiation. Okay. Okay, so this is useful when we have to differentiate a cumbersome product. Okay, let's say, okay, we just do example 11.5 here. Okay, okay, given y is equal to t squared, and then we have 1 minus t to the power of 8. Okay, so there is some power here, so we can use logarithmic differentiation. Okay, and then, okay, find dy over dt. Okay, so we have to take logarithm, okay, on both sides. So it will become ln y here, and then it will become ln, we can use other color, which is this color. Okay. So it will become ln, then ln t squared, okay, and then 1 minus t to the power of 8 Okay, so for logarithm laws, okay, if there is, this one is a product, right? Okay, which is multiplication of product. Okay, so use this. Okay, so we can convert into addition. Okay, so basically it will become ln. Okay, so ln t squared, and then we have plus ln 1 minus t to the power of 8. Okay, so next when we have power, we can convert it into constant. Okay, so it will become 2 ln t then plus 8 ln 1 minus t. Okay, that is loss. Okay, the loss of logarithm. Okay, so and then we just write the whole thing again. So it's ln y equal to 2 ln t plus 8 ln 1 minus t. Okay, so we are going to differentiate left hand side and right hand side. Okay, now differentiate left hand side and right hand side. Okay, so it will become d over dt ln y equal to d over dt. And we can put constant outside, so ln t and then plus d dt, put constant outside, 8 ln 1 minus t. Okay, so for this one, okay, have already did in the previous example. Keys d over dt ln y. Okay, this one. Okay, so this one. Okay, so for d dt ln over y. Okay, I want to give you some tips. If you are sleepy studying in the evening time, okay, just like this, you can stand up, okay, while studying. Okay, so the answer will be for dy dt is this one, 1 over y dy dt. Okay, 1 over y dy dt. Oh, okay, this is it. Okay, this one, so it is equal to 1 over y dy only, 1 over y dy dt equal to, okay, so this is 2 and then on t it will become 1 over t, then plus 8, so it will become 1. What is this? So actually I'm sleepy. I'm also standing right now, even though I'm at my home. Okay, so okay, so this one 1 over 1 minus t, like this. Okay, so we will have dy dt is 2 over t plus 8 over 1 minus t. Then the whole thing we just multiply with y. Okay, y transfer here. Okay, so now we have to convert back this y. Okay, convert into equal to, okay, t squared in bracket, is it 1 minus t, okay, minus t to the power of 8. So dy dt is equal to t squared I minus t to the power of 8, and then 2 over t plus 8 I minus t. Okay, that's it for logarithm differentiation. So now we straight go to the last one, which is higher derivatives. Okay, what does it mean by higher derivatives? Okay, so derivative here, okay, before this, you know, it is dy over dx or y prime. Okay, and this is also known as first derivative of y. Okay, with respect to x. Okay, so now we are going to find derivative of y prime. So this is called second derivative of y. Okay, so basically second derivative of y is we differentiate. Okay, we find derivative. Okay, derivative of y prime. Okay, which is this one. So it also can be written form of d squared y and dx squared, and also we can just y double prime. Okay, okay, so for example, okay, this one, okay, this is the simpler one, 11.18. Okay, if y equal y of x equal to 3x squared. Okay, and then plus 8x plus 9. Okay, so the y prime, okay, to find the y prime, just differentiate this one. Okay, with respect to x, so this will become 6x plus 8. Okay, and then if you want to find the y double prime or second derivative, you just differentiate this y prime. Okay, so it become 6 only. Okay, so let's have a look at last example, which is 11.20. Okay, so this is 11.20. Okay, so we have to find y double prime. Okay, second derivative. Okay, given 1 plus xy equal to x squared plus y squared. Okay, so this is implicit differentiation. Sure. Because we cannot, it is not in form of y equal to x. Okay, so cannot be separated. Okay. Okay, so what we have to do is we have to differentiate with respect to x, left hand side and right hand side. Okay, so differentiate okay the left hand side. Okay, so it will become d over dx 1 plus xy. Okay, so d dx 1 plus, this is linearity prop. Okay, xy, so this will be 0, So this one, we can say there is two function here. Okay. So what we can do is the product rule. Okay. And we have U and V. Okay. So we are going to use product rule. Okay. So the first one will be classified as U. Okay. Second one will be V. Okay. Product rule V. Okay. Product rule is V. Oh, sorry. V du plus U dv. Okay. And of course dx here. Okay. Look what the independent variable. Okay. What is the independent variable? So in this case it is x. Okay. So now we have to find du over dx. Okay. So du over dx is 1. And then dv over dx is dy dx. Okay. To dy. So we just write down here. So v is y. Okay. Y, and then we have du dx, which is, so v is 1. Okay, du dx is 1. Okay, and then plus u is x. Okay, okay, and then dv dx we have dy over dx. So basically it is this one. So it will be y plus x dy over dx. Okay. So 0. So this don't have to read. Have to write, sorry. So we just write down straight y plus x dy over dx. And then we have to do the right hand side. Okay. So this is the right hand side. Okay. So dx what is it? X squared plus y squared. Squared plus y squared. Okay, so dx plus power of 2 plus dx by the power of 2. So this one will become 2x. And then we have dx y squared. Okay, notice that this is different element, which is we have x and we have y. So this one we have to use the chain rule. Okay. Okay. So in this case, we will let z equal to y squared. Okay, so the main aim here is dz over dx. Okay, so dz dx will be equal, so dz over dy multiply with, we are going to eliminate y here. Dy over dx. Okay, so dz dy is 2y. Okay, so we just write down dz over dx is equal to 2y and then dy dx. So dz dx. Okay, so we just convert z into y2 again. So d dx into is 2y dy dx. So that's why we are having, okay, so 2x plus 2y dy. Okay, this one. This one here become this one through the chain rule. Okay. So we have to write back. Okay. Write back. Left hand side. Go to right hand side. Okay, the differentiation result. Okay. So this one is, we have y plus x dy over dx equal to, okay, right hand side, 2x plus 2y dy dx. Okay, so now we are going to group. This is quite long actually. To group dy. Okay, so x dy dx minus 2y dy dx equal to 2x minus y. So dy over dx is equal to 2x minus y, x minus 2y. Okay, and then we have to find the second differentiation. So we are going to have so it will become d over dx. Okay, dy dx equal, okay, so this is in quotient form, okay, which is fraction form. So we can classify this one as u, and then this one, the lower one, is v. So still remember the quotient rule, which is equal to v du minus u dv v squared. Okay, so this is in terms of x. So now you're going to find du dx. Okay, so du dx is 2 minus dy dx. Okay, and then for v dv dx is 1 minus 2 dy over dx. Okay, so y prime here, so this will become y prime. Okay, and then just have use the quotient rule. Okay, so v, which is x minus 2y, okay, and then du is 2 minus y prime, okay, minus u is 2x minus y, and then we have dv, which is y minus 2y prime, okay, over v squared. V is x minus 2y squared. So this is the answer. Okay, so that's it for techniques of differentiation. Okay, that's all. Thank you and Assalamualaikum.